Hello everyone. So today we are going to try Pascal triangle. That is the 21st uh, coding challenge of Leetcode daily challenge, 30-day challenge. So let's see what's the problem say. Given integer numbers, return the first numbers of Pascal triangles. In Pascal triangle, each number is the sum of the two numbers directly above it as shown. So this is Pascal where one will add to 2, then 1 2 will 3 and 2 1 will be 3. Similarly 1 3 will be 4, then 3 plus 3 is 6, like this. Now we whatever the number value is, we have to we have to return those many rows of this Pascal triangle. Okay, so it's kind of like storing, and the constraint is that numbers will be 30. So this looks like a rectangle, half of a rectangle. Like when we make a matrix, this is the top right corner, and then this is like this is the corner, one corner, and then these will be the diagonals. So if I take if it says that there are 50, we will have like 50 diagonals. These will be the 30 diagonals, and 30, so it will be like 30 cross 30 matrix. So that becomes easier if it is 30 by 30. Matrix, and it will be of numbers plus 1 and vector, just initializing a matrix grid of numbers by numbers. So numbers, and let's mark everything as 1. Now these corner will be same, so we need to start from this part. Okay, so actually if we go like, so it will be done like this only, so we need to traverse it with diagonals only. And diagonals, okay, so if I consider these are diagonals, how to traverse it in this way? It's like a BFS kind of traversal, but I'm not the BFS over here. um Taking the top and right cell value, top and right cell value, top and right cell value. So top and right cell value will be taken to compute this value, this top and right cell value. Okay, this is just one, don't care about this. This is top, sorry, top and right, top and right. So we traverse like this. So whenever we are at this point, it's stop and its right will be traverse. Okay, so we have to start traversing from the uh, like uh, from right side and going toward left and filling it like each row. Okay, so for int I is equal to 0, rows will start from zeros, I less than how many? Will be around num rows plus, let's do num rows plus 1 I plus plus, and for j we will go backward. J will be num rows and j greater than, how much will be j? Actually it is going to be, okay, but we have to return a vector of vectors, so this probably is not holding that. Other way that we could do is like add just first element to be added will be 1, and then when it's 2 we add 2, and then when we come to the third row we will take 1 will be there, and the element will be like, this is 2 second element, so it will be like 2 minus no, it will be 1 and 2, 1 and 2 elements. Yes, so if this is 1, it is 0, and 1 it is 0 1 2, so 1 is actually the sum of 0 and 1. 0 plus 1 is 1, and similarly when I come over here, this is 0 1 2, so this value 0 1 1 is actually 0 plus 1, so it is 1, then 2 is actually 1 plus 2 is 2. Okay, yes, yes, so this can, we don't have to do this then. Now we can just make a matrix which is actually we can push like matrix dot push back, and first row will be always be 1. Then we can push back, and the second element would be 1 comma 1, and now we need to iterate. Firstly we will just return if num rows is equal, num rows is equal to 1, we will just return matrix. Similarly, if num rows is equal to 2, we will return matrix. And finally, if it is more than 2, we will iterate that many times 3 I less than equal to num rows, and each time like um third row. For third row, we need to have something like vector of int. It's just a row, and row dot push. First element is of course going to be 1, and the last element is also going to be 1, and in between we need to push something which is from the previous element. I minus 1. This is going to be the I minus 1 row, so we will go like I minus 2 rows. Okay, so let's take it as 2, and this is less than numbers, and our int j is equal to j0. J less than how many times it will go? I'm at third row, first, second, third, fourth. So we see there are those many numbers only, whatever is the number of rows. So it will be same number, and already we entered 2, so it will be minus 2. But actually I should be equal because we are at 2, so it means it is at 3. So this would be I plus 1, but we already entered 2 elements, so this is going to be I plus 1 minus 2, so that is plus 1 minus 1. Okay, so now we entered. Now how are we going to, we already entered this element, now we are going to enter something. Let's make it as 1, and we'll decide what will come over here, and we'll take matrix of I and j. Okay, so I minus 1, and j is actually this element. It will always start from 1, so 1, and it will be 1 plus 1 minus 1. Okay, matrix of this element plus matrix of I minus 1, j minus 1. This is going to be row dot pushback. So we're going to enter each element, and then we are at 1 at this beginning, and then we're going to add the subsequent elements that will be the previous row element and the same column, and add addition of two numbers, and the two numbers will be the previous rows elements, that is at j and j minus 1. Okay, so actually j is 1, so this always holds, and I is also greater than 1, so this also holds true. So this way we are going to push until how much are we going to run it. It is like, okay, so I'm at 2 row, 0 base index 2 row, so 2 has 2 plus 1 numbers. Okay, 2 plus 1 numbers, so I plus 1 numbers, and 2 we already added, so it is I minus 1 numbers has to be added. So we are going to run from 1 till I minus 1. Yeah. This thing is perfect. And then we push this all, and then we can enter this thing matrix that push back row. And we come again, we make a new no row, return row matrix. And we also need to check whether if it is like 3 rows, so okay, this will not go. Yeah, this is fine. Let's run it. Something is wrong. Here it is not running properly. The third has not run properly. Why? I entered this, and then we got into the third row. Okay, so we started with 2. So we started with 2, and here we entered 1, and here we entered 1. But will this enter over here? I minus 1 is 1. So it will not go into this. Okay, so this has to be equal. Now it looks good. There is 5, 1. Let's try with 1. Number can be 1 to 30. Let's also try 30. It is looks like it's correct. Yeah. Okay. Done with this problem. That's it. This was the easy problem. Let us just check what is this, whether it is hard or medium. It is medium or easy problem. It is easy problem. Okay, so we are done with this. Let's see the solution. Okay, solution is showing a dynamic problem. It is doing something like that, but how is it going to return? If we have the rows of Pascal triangle, we can easily compute the next row by each pair of adjacent values. Although the algorithm is a simple iterative approach to constructing Pascal triangle can be classified as TP because we construct each row based on the previous row. First, we generate the overall triangle list, which we store each row as a sublist. Then we check for the special cases of 0 as we would otherwise return 1. Since num row is always greater than, we can initialize triangle with 1 as its first row and then proceed to following rows. Let's see what's doing. It's adding 1. Oh, yeah, we did the same thing. We actually did the same thing. It's adding 1, and in each of them it's adding 1 and then adding 1, and the rest of them they are finding from the previous row. All right. Yeah, so the complexity of this is, let me just achieve, complexity of this is yeah, because there will be like n number of rows, and in each row there will be like ith number of elements, so we have to compute each of them. So it will be like if you are given numbers as n, so there it is that the number of elements will be n into n minus 1, n into n plus 1 by 2, so it's almost like n square elements, n square complexity. Usually a triangle happens on constant time. It is preferred these times to see why considered how many overall loop. Yeah, means it is like 1 plus 2 plus 3, 2 nums of row, which according to Gauss formula is nums into num plus 1 by 2. So this is order of number square. Okay, that's it. Thank you.